All right, guys. A lot of video tutorials today, but I'm gonna get back in. So we're doing function. We're doing functions. The second week of functions, 2020 summer session. All right. So a lot of important stuff, important vocabulary and intervals, rates of change. So it could be difficult if you don't listen, but hopefully you're watching and ready to take notes, and then you'll be like, it's not bad. And if you don't do that, you'll be like, I don't know what's going on. So the first thing is determine the domain of functions. That is all these questions. Okay, so the domain of a function, that means what values, what numbers can I substitute for x? What a question. You think, what does it matter? Can I substitute any? Zero? Will zero work? Well, it turns out that most of the time you can substitute in anything. And if you can substitute anything in, that then you say the domain is all real numbers. Real numbers are pretty much, until you get to algebra 2, there every number you know can be substituted in. Then if that's the case, you say the domain is all real numbers. Or you could say negative infinity to positive infinity. To infinity and to negative infinity. All right. But sometimes there's some rules in math that do restrict a couple of numbers from being in the domain. One rule is you cannot divide by 0. Cannot divide by 0 and cannot square root negatives until you get to algebra 2, and then you learn that there is a way, but it's not a real number. It's called an imaginary number. So we're not doing imaginary numbers in algebra 1. Okay, so let's get to it. Here are the steps. To find out what is the domain of f, we're going to circle the denominator, and we are going to set the denominator equal to 0, because I said you cannot divide by 0. So we cannot have 0 end up in the denominator. If we had that like 7 over 0, that is undefined. You can even put it into a calculator right now. 7 divided by 0, it will give you an error. Okay, so 0 would be fine. 0 is in the domain of this, and I'm going to show you that if I substitute 0 in, I end up with negative 3/2, which is fine. But, okay, set the denominator equals 0, solve it, and we get negative 2. So watch with me what happens when I substitute in negative 2 to this function. On top, we're fine. That's negative 5. But on the bottom, we end up with 0. And negative 5 divided by 0 does not have a value. It's undefined. So x equals 2 makes the function not work. So we say that the domain is all real numbers, or I just shorten and say all reals x not equal to negative 2. That's how Mr. Fields says it. All reals such that x is not equal to negative 2. Okay, second one, you see the denominator is 2. So no matter what value you substitute in for x, x is only on the top. So you can't make this one have a 0 in the bottom. It will always have a 2 in the bottom. So the domain of G is all real numbers, or all reals. That's what the cool people say, right? The cool people being me. Maybe I'm not cool. All right, so x minus 5 is in the denominator here. Okay, so I just automatically set it equal to 0. We're going to solve that. We get 5. So do you know what the domain is? It's all reals x not equal to 5. I substitute 5 in, I'd get 4 over 0. Okay, so those are the fractions. Don't set the numerator equal to 0. You only set the denominator equal to 0. What is the domain here? Well, you see the square root sign, and you see we cannot square root negative numbers. So we cannot have a negative inside the square root. That means that x minus 10 must yield a positive result. Must be a result greater than 0. So instead of equal, now we use the greater than sign, and then we solve, and we get x is greater than 10. So this would be all reals greater than 10. Or, you can word it differently, but that is the domain. All right, so there you go. The next one is domain word problems. And there's 2 parts. You have to say what kind of numbers are in the domain, number type. So it's going to say, is it integers or is it real numbers? And so real numbers are everything, and integers are only the integers, that means no decimals. So basically they're saying, are decimals allowed or are decimals not allowed? For the domain, not the range. So let's see, what is the domain? The domain is the variable on the inside of parentheses. So what does n represent? The house numbers on a certain street go from 1 to 88. The function b of n models the type of the building whose number is n. Okay, so the type of the building whose number is n. So b of n is a building type, but n is a building number. Well, I live at 1488, but I don't live at 1.482, something like that. There's no decimals in addresses, but maybe there could be. Actually, I do have a cottage in Michigan, and there's a half in it. Sometimes you get a half, but generally, and in this problem, we're not talking about that. We're talking about the fact that building numbers, and it says from 1 to 88, so it's telling us integers. So there are integers for the building numbers, and if they go from 1 to 88, then our domain is going to be 1 is less than or equal to x, which is less than or equal to 88. There you go. All right. So Aiden is a spice trader. He sells any amount of cumin seeds from 1 kilogram to 1,000 kilograms. He charges $5 for 1 kilogram and $2,000 for 1,000 kilograms. P of W models the price in dollars of W. So W is that weight, is the kilograms, and P is the price. So can weight be a decimal? Can you be 1.25 pounds? Yeah. So we're going to say real numbers for work for kilograms. So real numbers for the domain, because decimals are okay when we're talking about weight. So what are we talking about for the actual domain? Okay, so this guy from 1 kilogram to 1,000 kilograms. Okay, so there you go. The minimum he's going to sell is 1, and the maximum he's going to sell is 1,000. So min, max. That's the domain. All right. So the next couple of assignments are looking at graphs and tables. And this one is talking about maximums and minimums. When we're talking about maximums and minimums, we can have a relative max or min, and we can have a absolute max or min. Okay, so the relative max or min is it's the max or minimum point relative to what's around it. So, you know, like I'm not the tallest person in the world, but I am the tallest person in my house. So, you know, I have a relative maximum of height in my house. But if you look at my neighborhood, now maybe I'm not the tallest anymore. To what is around it. Absolute max or min is the highest or lowest point, you know, overall. And sometimes there isn't. Sometimes it goes up forever or down forever, and there is no max or min. But let's look at this graph here. And we'll consider that it goes on forever in either direction, but we, I guess we can only really talk about this because we don't know if it keeps swerving and turning and stuff. So on the part of the graph that's shown, even though it may go on forever, this point right here is a relative max because relative to the points around it, it's the top of a mountain, right? And this is a relative minimum because relative to the points around it, it's the lowest point. But you can see that there's a point lower. There's a lot of points lower than this point, but it's a relative minimum. This is also a relative minimum. And do you see maximum? Right here, this is the highest point on the graph right here. So we're going to call that the absolute maximum. And this is the lowest point on the graph. We're going to call that the absolute minimum. So that's how that works. You can ask your questions as you work on the assignment, but that's the idea. The last assignment is important because it's talking about the average rate of change. The average rate of change is slope. So you guys should remember calculating slope. And not everything in life is a line, but we can always use average rate of change to understand things. So, you know, maybe you know about lines of best fit, or in this case, we're going to draw, you know, we could draw a line right here. So even though this is swerving, generally it's going up in a straight line, right? And even with these, you know, our data that we're getting in our country, they're making all kinds of lines and stuff and curves to understand that. So you need to know how to calculate the average rate of change. And it's not too bad. So they give us the x values. And we know that the slope is y2 minus y1 over x2 minus x1. And we have our x's. So what are our y's? So in other words, we know -7 something and we know 2 something. So let's just look at the graph. -7, what's the value of the function at -7? It's -7. And what is the value of the function at 2? It is 5. So, and if it gives you a table, you can do the same thing. Just figure out what the y values are, what the x values are, and then calculate your slope. So my y2 is 5 minus my y1 over my x2 is 2 minus my x1. So that is 12 over 9, which I can simplify. You can divide both of those by 3. And so that is 4 over 3, 4/3. So I would say the average rate of change over the interval -7 to 2 is 4/3. All right, please post all of your questions on Google Classroom and be ready to ask them in class. See you there.